Geometry, Unit 9, Section 2, Trig Ratios. So the previous chapter was trigonometry, but it was really just an introduction to trigonometry with stuff with right triangles. We learned about some special right triangles like the 30, 60, 90, 45, 45, 90 right triangles, and we're going to see those again, I think in Section 9.4. But we also did some Pythagorean theorem stuff and some geometric means, similar triangle proportion stuff. So now we're really going to start to get into what most people call trigonometry, you know, the things with sine, cosine, and tangent. And this might be your first time working with these functions. Sine, cosine, and tangent, what you just have to realize is that they are just ratios, just like we've been doing. We've been working with similarity now for months, you know, saying that, you know, a 30, 60, 90 triangle, the opposite to 30 is half the hypotenuse, and that's no matter how big or small the 30, 60, 90 right triangle is. The opposite's half the hypotenuse. The hypotenuse is 10, the opposite's 5. The hypotenuse is 20, the opposite's it's 10, but it's a ratio of 1 to 2 regardless. And that ratio would actually be called the sine ratio because sine is the ratio of the opposite to hypotenuse side. So trigonometry is really just an extension of right triangle similarity. So, but before we get into the sine, cosine, and tangent ratios, first we need to just clarify a couple of terms that we're going to be using quite a bit, opposite, adjacent, and hypotenuse. So what side is opposite angle A? What side is adjacent angles A? What is the hypotenuse? Now, what is the hypotenuse? The side is AB. AB is the hypotenuse, and AB is a length of 13 here, but we'll just call it AB. This is the hypotenuse regardless of what angle we're speaking of. But when we talk about opposite and adjacent, those are relative terms, meaning that what's opposite for angle A is not what's opposite for angle B. They have different places in the triangle, so the sides opposite them are different. So when we call a side opposite, it's relative to the angle we're referring to, and same thing goes for adjacent. So opposite and adjacent, you know, this side here is opposite, but that it's only opposite angle A. It's actually adjacent to angle B. And then this side over here, AC, well, it's opposite B, but it's adjacent to A. So it depends on what angle. So the angle you were using or speaking about has a lot of perspective and a lot of relevance. So opposite angle A across from angle A is BC. And opposite angle B across from angle B is AC. Adjacent angle A. Now, adjacent means basically next to. But adjacent to angle A, there's two sides next to it. This side is adjacent to angle A, and this side is adjacent to angle A. But when we're referring to adjacent, we're not talking about the hypotenuse. The hypotenuse is called the hypotenuse. The legs we refer to as either opposite or adjacent. And for angle A, AC is not opposite, AC is adjacent. And adjacent to B is BC. And you'll notice that when it's adjacent to the angle, it might have that angle as one of the letters because it's connected to it, adjacent. Opposite, you know, opposite B, you're not going to see B in the side that's opposite B because it's completely across to it, it's not connected to it. So that's just some terms that you need to really be familiar with. All right, the sine, cosine, and tangent trig ratios. There are three of them. There's actually three more you're going to learn next year in Algebra 2 called the reciprocals of these. But this year we only start off with the basic three, sine, cosine, and tangent. And all they are, they're not magical, they are just ratios. It's the ratio of the opposite side to the hypotenuse side. When I'm comparing, you know, for angle A, for example, it's opposite length and it's hypotenuse length. When I'm comparing opposite and hypotenuse, I'm working with the sine ratio. Just like what we said for the 30, 60, 90, that opposite the 30 is half the hypotenuse. That means that sine of a 30-degree angle is 1/2. The ratio of opposite to hypotenuse for sine 30 is 1 to 2. So we've already kind of talked about that a little bit in those special triangles. So sine is the ratio of opposite to hypotenuse. Cosine is the ratio of adjacent to hypotenuse. These two are very much connected, sine and cosine. First of all, sine and cosine sound kind of similar, where cosine is the word sine with just co in front of it. That has to do with something called cofunctions, which is actually the topic of the next lecture. So we're going to get more into that next time. But sine and cosine are so connected because opposite and adjacent are so connected. You know, like this 5 over here, BC. This is opposite A, but it's also adjacent to B. So this is considered an opposite for A, and it's considered an adjacent for B. So depending on what angle you're referring to, this side can be considered opposite or adjacent. And so sine and cosine, they're both divided by the hypotenuse. They're both comparing legs to the hypotenuse. And there's only two legs in the triangle. And so sine and cosine have a lot of important connections, and we're going to explore that in the next couple of lectures as well. So leg to hypotenuse, that's sine and cosine, just depending if you're talking about the opposite leg from the angle you're working with or the adjacent leg you're working with. But they're both comparing leg to hypotenuse. Leg to hypotenuse. That's what sine and cosine are doing. And then there's tangent, and tangent is really separated from these two because tangent doesn't compare anything to the hypotenuse. Tangent's comparing the two legs to each other. So the opposite leg compared to the adjacent leg for a specific angle. What's that ratio? That's your tangent ratio. And tangent also can be thought of as sine theta divided by cosine theta. And we're not going to talk a lot about this today, but this will come up throughout trig and definitely a lot next year. The tangent's opposite over adjacent. It's also sine over cosine. Now think about it. If I divide sine divided by cosine, that's opposite over hypotenuse divided by adjacent over hypotenuse. The hypotenuse end up canceling out, and you just have opposite over adjacent. So tangent really is separate from these two. Sine and cosine are working with specific legs to the hypotenuse. Tangent's kind of combination of sine and cosine because it's working with both legs. So keep that in mind. Tangent is working with both legs. And we'll talk a little bit about tangent today, but then we kind of take a break from tangent and we focus more in on sine and cosine and their relationship with each other. And then we're going to have a special day where we just talk about tangent. All right, so how can we remember this? We use this acronym SOHCAHTOA to help us remember it. SOHCAHTOA. And what it just means is sine is opposite over hypotenuse, cosine's adjacent over hypotenuse, tangent's opposite over adjacent. Sometimes we write it like that. This just needs to be memorized. You have to know sines opposite over hypotenuse, cosines adjacent over hypotenuse, tangents opposite over adjacent. Just really commit that to memory, whether it's on your reference sheet or not. I'm not really sure, but just really commit that to memory because that's going to make trig a lot easier if you know that. So what is the ratio of sine A? Quick time check. We're doing good. What is the ratio of sine A? So sine is opposite over hypotenuse from angle A's perspective. Opposite that is 5. Hypotenuse is 13. So the answer here is 5 over 13. It's a weird looking 5. 5 over 13. It's not much better. How about for sine B? Well, from angle B's perspective, what's opposite B is 12, and the hypotenuse is 13, so that would be 12 over 13. How about cosine? Cosine A, adjacent A over hypotenuse, 12 over 13. For B, cosine B, adjacent to B over hypotenuse is 5 over 13. And you'll notice that sine A and cos B are the same, and sine B and cos A are the same because flip-flopping from angle A to B also flip-flops what's opposite and adjacent. Like this is opposite angle A. Well, it's also adjacent angle B. That's why sine A and cos B are going to be the same. And then tangents, you're comparing the two legs, opposite over adjacent. So from A's perspective, opposite is 5, adjacent is 12, so that's 5 over 12. And for B, opposite over adjacent is 12 over 5. And you notice that when you go from tangent of one acute angle to tangent of the other acute angle, you end up with the reciprocal. Because it's just the two legs, and there's only two ways to compare the two legs. Small over large, large over small, opposite over adjacent, adjacent over opposite. So that's just kind of labeling, knowing what the trig functions are, knowing what opposite is, and you're just going to write them as ratios. Then we give you problems like this. For triangle MTH, angle T is 90 degrees. That's important that we know which one's the right angle. That means that M and H are the two acute angles. Cosine H is rad 11 over 6. Determine the ratio for sine H and tangent M. Anytime they don't give you a picture for a triangle problem, it's always worth it to draw the triangle. And again, this is why it's so important that they tell me that angle T is 90 degrees. It doesn't really matter where the M and H go. I'm just going to put the M there and the H here. It will work either way. Then when they tell me cosine H is rad 11 over 6, we have to remember what cosine is. Cosine is adjacent over hypotenuse. So that means they're telling me the hypotenuse is 6, and what's adjacent H is rad 11. Well, adjacent H, this is opposite H, so this is adjacent H, so that's rad 11. And I have 2 out of 3 sides. Now sine H is going to need this missing side, and tangent M is going to need this missing side, so we have to find that missing side. But we've known now for a while that when we have 2 out of 3 sides of a right triangle, we can find the third with the Pythagorean theorem. So that's what we apply here. And that's just x squared plus rad 11 squared is 11, 6 squared 36, subtract 11, x squared equals 25, so the square root, our missing side is 5. So this is 5. Now that I know this, I can figure out what sine h is. Sine h is what's opposite h, 5, over the hypotenuse 6. And tangent m is what's opposite m, rad 11, over the adjacent. Tangent's opposite over adjacent, so opposite rad 11 over adjacent, that 5 we found. So you really do need to be I almost slipped there for a second thinking tangent was opposite over hypotenuse. No, that's sine. So you really need to take time to commit those ratios to memory, remembering which one's opposite, over hypotenuse, which one's adjacent over hypotenuse, which one's opposite over adjacent. It'll take a little practice getting used to this, and you might have to use this as a reference at first, but it will become second nature to you, and you're going to be using this for many years to come. See ya.